I hope you enjoy the following class. Do realize all of these video classes are based on what I teach at Silicon Dojo here in Asheville, North Carolina. These are free to the end user, hands-on technology classes where basically you just sign up, you show up, and you get to learn technology. I will remind you that free to the end user is not actually free. All of this stuff costs me a shocking amount of money. So if you would like to support the educational programs that I am creating, the education that I deliver, please think about clicking on the donor box link down below and throwing a couple of dollars in for the cause. I hope you enjoy this class, and more importantly, I hope to see you at Silicon Dojo sometime in the future. Welcome back. As you know, I am Eli, the computer guy, here for Silicon Dojo, and today's class is Introduction to the DALL-E API. So I think the DALL-E API is really cool. At least as a proof of concept. And I'm a bit surprised more people are not talking about it. So we're talking about DALL-E. This is an AI service from OpenAI that generatively creates images for you, it edits images for you, or it creates variations of images for you. And because we have an API with it, what we're able to do is we're actually able to write Python scripts in order to dynamically access the API, acquire images from OpenAI, download them, and do whatever it is that you want to with them. So one of the projects that I did with Silicon Dojo that was kind of interesting for the students was basically come up with an AI-powered Instagram. So all of the images in our little quote-unquote Instagram feed were actually created by DALL-E, and it was a good way to get them used to playing with Django and making API calls and parsing JSON and all that kind of stuff, right? So that's one of the kinds of things that you can do with the DALL-E API. Basically, you're able to interact with it through Python, not just through some web interface. Now, you might be sitting there going, well, wait a minute, that was kind of a backhanded compliment. Is Eli, the computer guy, negging OpenAI? No. No. DALL-E, at least the API version of it, is very much what I would call a proof of concept. So there is DALL-E 2 out there, right? So if you go to the web interface that OpenAI provides, you can use DALL-E 2, and that is actually pretty decent, right? There's a whole generation of this generative image AI out there. You have Midjourney, you have DALL-E 2, you have some of the other ones out there, and they're all, same but different type of deal. I actually pay for Midjourney. I actually find Midjourney to be very good when we do the meetups for Silicon Dojo, and frankly, I just need a featured image. I just need to slap up an image that kind of sort of looks like whatever class that we're going to be teaching. I just go to Midjourney, I go /imagine, I don't know, a talking computer or a singing computer, whatever the hell else, right? And I slap that up. The thing is, I do not use the DALL-E API. And the reason is, it looks like a kindergartner did it, right? If you go to Midjourney or whatever, DALL-E 2, it actually looks like a college student, at least, was the one coming up with these image creations. When you go to DALL-E, the API version, it very much looks like a kindergartner. Now, so some people out there, right, they're going to be watching this video, and at this point in the video, they're going to want to turn it off. Why am I going to learn about a subpar product, Eli? Why are you wasting your time, Eli? How much money has OpenAI paid you? To be clear, none. To be clear, none. I'm open to payment, though. I am open to payment, but I have paid OpenAI. Why I find this to be interesting is, again, remember in the technology world, things always get better. They get better relatively quickly, except for DALL-E. The API. It's kind of been crap for about 6 months at least now. Hopefully it'll get better soon. One of the things that I think is interesting with this, and again, one of the things I teach at Silicon Dojo, is the concept of service-oriented architecture, right? So when we design systems in the modern world, we have to think about the architecture with how we're designing these systems. So back in the old days, we had something called client-server architecture. So you would have a Windows NT client operating system, you'd have a Windows NT server operating system, you do some configuration files to connect them into something called a domain, and that was a client-server architecture. And a client-server architecture is a real pain in the butt when you want to change services out. If you decide you want to migrate from Exchange email services to who the hell knows what you're gonna, Novell or whatever, GroupWise or something like that, it's a long, hard, tedious, nasty process that nobody ever wants to do. You never want to migrate across entire product lines in the real world of IT. Do your research first before you buy the damn product to begin with. Here's the thing though, right? It's in the 2020s. 2020s no longer, I know this is a shock, this is no longer in the 2000s, and so we have a different architecture style nowadays. So you hear about service-oriented architecture, or you might hear about microservices architecture, and there's a whole bunch of different architecture styles. Anyways, the important thing to understand about this is in our architecture style, when we're designing systems, when we're designing platforms, the idea is each service that's being provided for the platform that we're created should essentially be widgetized. It should be something that basically you can swap in and out as need be. So think about this like with Twilio, right? So Twilio provides SMS services. So let's say you create a platform, you want to send SMS messages, text messages to your users or whatever else. You decide to use Twilio because they're solid, good reputation, whatever. The price point isn't too bad because you're sending out, 10 SMS messages an hour. You frankly don't care. Well, here's the thing. What happens if you become the next Facebook, right? What happens if your dog dating app takes over the world? And all of a sudden, instead of sending out, 10 text messages per hour, you're now sending out 100 text messages per second. All of a sudden, Twilio's pricing model went from something you really didn't give two craps about to, again, bankrupting your startup company. So one of the things that you can do is you can go out to a different SMS service provider. You can look for something somebody that might give you a better price point for the amount of SMS messages that you're sending out. You create an account, you get an API key, you literally swap out 5 lines of code. And now all of a sudden you're using this other system, other providers' SMS system instead of Twilio, right? That's what we talk about with service-oriented architecture or possibly microservices architecture. So why I think this is kind of interesting right now is you can build systems. You can play with DALL-E right now. It's in the production world. You can pay for it the whole 9 yards. You can build it into your systems with the understanding it's pretty crap until the point where you find an API that actually is pretty good. So I've been out there. I've been trying to find other better generative image APIs out there. Again, not platforms, not that you log in and it provides a picture to you. Again, an API where I can simply write Python code, make my request, parse the response, that type of thing. And I actually haven't been able to find better APIs up until this point in time. And so one of the valuable things with this is, again, it's already with OpenAI, so you should be playing with OpenAI already. It does actually give you this generative image functionality, so you can start playing with that, start embedding this into the platforms that you're creating with the idea that hopefully in 6 months, whether it's OpenAI or somebody else, comes out with a much better API, and then you swap 5 lines of code and go over to that. But if you understand the concept of DALL-E, you'll be able to understand the concept of swapping those 5 lines of code. And so that's a very long-winded reason for why we're talking about this today. Is it cool? Yes. Would I put it into production? Hell no. Hell no. Unless it's for kindergartners. I guess kindergartners would like it. Anyways, before I go any further into this particular class, let's actually go over to my machine. So I'll do a demonstration for you so you understand what we're going to be learning today. And then we'll dive into the class and I'll show you how to do the API calls and all that kind of cool stuff. So here we are at my very sacrilegious demo computer. This is actually a 2013 MacBook Pro that, yes, I have installed the latest version of Ubuntu desktop on it. And I've got to say, it works like a champ. Absolutely awesome. Again, the lab computers that we use for Silicon Dojo, they are actually 2012 MacBook Pros that we put Ubuntu onto, and they are just fantastic. High quality Apple hardware, high quality Ubuntu operating system. Again, costs you, I don't know, about $150, and that's it. So anyways, that's the system that we're using here. All of the code that I'm showing you today should work on any system. So whether you're using Windows, whether you're using Mac, or whether you're using Linux, I do not believe there's anything here that's specific to an operating system. But as always, That's up for you to troubleshoot and you have issues. So anyway, so this first thing right here is basically we have a prompt of a kid riding a dog. Anyways, a dog's a little boring. Let's say a kid riding a cat. So what we're going to do is we're going to make a request of a kid riding a cat. We're going to ask for 3 of them. The size is going to be 1024 by 1024, and then we're going to get the response. Again, I'll explain all this to you later. I just want to kind of give you the idea of what happens here. So I run this. Again, so this is all an API call. This is all in my Python code. So this could be built into a Django web application, that type of thing. And anyways, here we go. We have 3 images from DALL-E. Are you ready? Are you ready for nightmare fuel? So we click on this and we do open. And the first image is, there we go. We have a kid riding a cat. Again, we get 3. We click on this one. We open it. And we get a kid riding a cat. We come down here. We click on this one. And we open it. And we get another kid riding a cat. So this is the quality of the DALL-E images that you get. It's kind of interesting now. They're not doing as many photorealistic images as they used to. I don't know what that's about. So anyways, there you go. This is actually getting better. The faces are decent. I know this may not seem like a big deal. The faces used to be very, 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 very scary. So anyways, the first project that we're gonna talk about is basically this, where we simply get the URLs for the DALL-E images that are created. The next one what we're going to do is we're going to actually explain how to download the images. So the images are not actually downloaded by default, so you do have to code to get them to download by default. Then we go over here to where we basically ask for a variation of an image. All right, so let's see here. If I go over here and I open this image of Musk, you will see I have Elon Musk with a blank background. So we want to fill in that background. So here we're going to say, picture at a taco stand on the moon. Because, you know, if Elon Musk is going to be eating a taco, he's not going to do it in the suburbs. So anyways, again, we're doing this nice little API call. It's going up. It's requesting for a picture of this person, Musk, on the moon, and hopefully in a second we will get the response back. And we have the response there, and basically I can come here, I can do control, I can click on it, I can open it. Hey, I know, there you go. What does that have to do with anything? I don't know. Look, there's a moon there. That looks like a flying fish, and it says Tizo. It says Tizo, obviously. So yeah, you know, it's one of those things. From a technical standpoint, this is awesome. Don't put it in the production world unless you want to scare the kids. And then the final demonstration that we're going to do today is basically where we can do variations, which I think is actually kind of interesting. So if we go and we open my pets picture, so I have this pets.png picture, open this up with Firefox. Basically what we see here is we see a corgi and we see a cat. So what I'm going to do is I'm going to run this particular script, and it's going to give me 5 variations of that particular image. And in this project, we're actually going to be writing this to an HTML page, basically as an image gallery. So we come here, let's see, I do modified, I look at variations.html. And so there we go. Again, not the worst thing at the end of the day. So this is the original. So we have a green border around the original, corgi and a cat, corgi. And whatever that is. That's a corgi and a cat. I gotta say, that's actually not too bad right there. Another corgi and a kind of a tiny cat. Corgi and a cat. Corgi and a cat. It's actually getting better. Only 1 out of 5 images is disturbing enough to give a kid nightmare. So anyways, that is what I'm going to be showing you how to do today. Everything from creating an image to editing an image to creating variations of images. I've got to say, I'm actually a little disappointed with that demonstration, and it goes to show you how these systems are being constantly improved. I started teaching a variation of the class that we're doing today probably 3 or 4 months ago, and let me tell you, that crap was nightmare fuel. You would ask for an image, and what you got back looked like it should have been at a Hellraiser or something like that. I do find it to be, honestly, a little bit interesting that the images nowadays, again, might not actually make half a bit of sense, especially with the editing an image, but they're not nearly as scary as they used to be. And again, this is kind of one of those things to show you what's kind of cool about service-oriented architecture is that they are always improving. You just make your API call and they're improving their systems. Though you do have to be careful, one person's improving is another person's degradation. I mean, if you were trying to come up with concepts for the next Hellraiser movie, these images are just definitely not going to help you out. So again, that's one of the other things to always be thinking about, especially with these AIs, these AI APIs, these generative AI products. The reality is that the quality, the overall quality of the product that you get from week to week may actually change in significant ways, and depending on what you're trying to do with these systems, that may or may not matter. So anyways, from here, the important thing is that you're going to need to get the API key. So if you took a look at the code, you'll see an API key. Don't worry, that API key will be deleted by the time you're watching this particular video, but in order to do these projects, you are going to need that API key. You will need to create an account with OpenAI. I want to be very clear here, not ChatGPT, OpenAI. So ChatGPT and DALL-E, they have different, DALL-E 2, they have different membership levels. So the ChatGPT 4 now costs people like $20 a month, and then they have DALL-E 2 that costs people whatever it costs per month. Those are the platforms, right? You log into that. It gives you a nice little prompt. You ask your question, you ask for an image. It gives you that. That's a platform. We are not dealing with that. We are dealing with the API. So with the API, again, we're going to be basically getting the API key, and then we will be billed for how much we use that API key. The pricing for images is not too bad. A 1024 by 1024 image comes out to 2 cents as of right now, comes out to 2 cents. I think it's a 512 by 512. It's something like 1.6 cents. And I do believe a 256 by 256 image is something like 1.4 cents. Just for me, I will tell you, I always go with the 1024 by 1024 when you're saving half a penny per request. I think it makes sense because remember, this is generative AI. So if you ask for an image, it gives you the image, and they're like, darn, I wish that was in higher resolution. Again, it's not like Google or Shutterstock where you can just get the higher resolution version. It literally created that image for you on the fly. So you can do the edits, you can do the variations. Maybe you might get something better, but be careful about it. I would say for that half of a cent, especially if you're not in a production environment, just pay the 2 pennies. The other thing, the full 2 pennies. The other thing that I'll say with this is, again, you get to request a number of images, and they're between 1 to I don't know what the max is. I guess you can probably ask for 100 if you wanted to. Do realize it's 2 cents per whatever that number is. So if you ask for 5 images times 2 cents, that's 10 cents every time you make a request, right? Especially when you're in testing process and all that kind of thing. Just remember, every time you hit the run button in VS Code, you are going to get billed 10 cents or whatever it is. Just kind of keep this in mind. Again, the joke in the Silicon Dojo classes is please don't bankrupt me with while true loops. This crap can get expensive quick. Anyways, with that, let's go over to my MacBook. So my MacBook is where I do my normal stuff. It's my daily driver. Let's go over there. I want to show you the API interface, how to get the API key, that type of thing. So here we are. Yes, we are on my M2 MacBook Pro with the actual Mac OS. Again, all the code that I'm showing you today should work on this particular computer or a Windows computer. I just try to keep the demonstration streamlined with our lab systems, just so people don't get confused about that kind of thing. But again, right now, we're actually going to have to get that API key. So we come, and again, you're going to be coming to OpenAI. If this is not more or less what you're looking at, make sure you go to OpenAI.com. You're then going to go to get started or log in. I have an account, so I log in. And once I log in, I get these 3 panels. So ChatGPT, this takes me to the platform. Not what I want. DALL-E, this takes me to the platform. Create realistic images. Oh, that's not what we're using today. We're using the API. We're going API. We get something. We get images. Anyways, once we come to the API, again, this is what we saw before. If you've been taking my other OpenAI classes, we have the API reference here. If you're looking for references for these images, we can come here to images. So we can do create an image. It will actually give you the code, Python, Node, or curl theoretically. It'll give you the code for that. How to edit an image. It'll give you the information there. And then how to create image variations. Again, this is what we're going to go over today, so I'm not going to talk about this a lot, but all this information is here in the API reference. What we're going to do is we're going to go over to this personal link up here, and then we go down to the personal link, and we're going to do view API keys. So we're going to have this thing for API keys. Basically, you're going to create a new key. So I do create a new secret. I give it whatever name I want to give it. Create the secret, the key, and this is the key. So this is the key that will be sent up with your request to say what account is responsible for this particular request. Once I hit done, this goes away forever and ever. Right? You're not going to be able to get a copy of this key once you hit done. So do make sure you copy it before you hit done. Once you hit done, basically this is where it shows you the last 4 characters of the key, so you can manage it, but there's no way to get it. You can edit the name, you can delete it. That's all you can do. You can go over here too, like to usage. It shows you the usage. Again, it doesn't really cost you much in order to do this. One of the important things is come to billing, and then you probably want to do usage limits if you have not done this before. With the usage limits, you can put a hard limit in here and a soft limit. So again, even though this only costs 2 cents, per image, that can build up if you start doing loops. Do be careful. So I have a soft limit here where it emails me after I hit $5, and a hard limit of once I hit $10. I have not hit $10. I've only hit $5 once so far, but a hard limit of $10 just to make sure I don't go bankrupt using this particular system. So this is what you need in order to get your API key. Again, plug in your credit card information, and you should be able to use this relatively quickly. So now you have your API key. You know how to get it. Hopefully you have put in the soft limit and at least the hard limit so you don't go bankrupt using this particular system. And now that you have that information, what we can do is we can go in and we can start working with this demonstration code so that I can explain to you how this works. I will say with DALL-E, the code is much more simple than even ChatGPT 4 or ChatGPT 3.5, right? With ChatGPT 4 and 3.5, you have roles, you have a single system role, a single user role, multiple assistant roles. You got a whole bunch of stuff going on there. The interesting thing with DALL-E is you don't have that. I actually wish you did. I wish you had a way to guide the images a little bit more, but basically all you have is your query, how many you want, what size you want, and that's it. One of the weird things I will just remind you for all of this class is they have a weird thing with image sizes. Again, 256 by 256, 512 by 512, 1024 by 1024, and that's it. That's it. You want something else? You get to copy and paste or crop or whatever, what it is that they give you. When you're requesting images, that's not that big a deal. Where it becomes more frustrating is when you edit an image or you do an image variation, you still have to feed basically a square image, 256, 256, 512, or the 1024. If you feed any other image sizes, it will fail out. And that can be a bit of a pain because most people don't deal with those image sizes. So you literally have to take the image, you gotta put it over into your image editing software, you gotta crop it to whatever size, readjust the canvas size, save it, then you upload it. Again, it's one of those things, it's a pain in the butt if you realize it's there. It's pretty easy to deal with, but do keep that in mind. So anyways, the first lab that I want to show you is basically simply how you are able to request images from the DALL-E API. So here we are at my Ubuntu computer, and I'm using VS Code because it's the 2020s and everybody uses VS Code. The one thing before we actually start playing with VS Code is we do have to install the OpenAI module. So this being Ubuntu, we use pip3. So depending on what operating system you're using, it will either be pip or it'll be pip3. We do install OpenAI. This will go up to the repository, and it will download OpenAI and install it for us. Again, it's already installed here for me, so it's no big issue, but you will have to install that first into your Python environment. So if you're using a virtual environment, obviously install it to your virtual environment or onto your system just to be able to make this stuff work. So anyways, now let's go over and take a look at the actual code. So we take a look at this. The first thing that we're going to do is we're going to import the OpenAI module into this particular script. Then we are going to feed it the key for OpenAI. So this is that key that we just, well, actually not that we just got, but that I previously got for this project, and now it'll use that key. Now again, this should probably, if we're doing this actual in the production environment, this should be something called an OS variable. So you would actually save this key as an OS variable. You would then call that OS variable, but that adds a bit more steps into all this process, and I don't want to make you too confused. But yeah, if you're going to do this in the real world, it should be an OS variable. Then beyond that, basically, this is the code right here. It is really, really simple, right? A response equals, so we're going to create a variable called response. It is going to equal openai.image.create prompt, a kid riding a cat. Let's put photorealistic. I'm doing this in real time. Realistic. I have no idea how it'll turn out, but I want to show you the photorealist. Maybe that'll scare you. Anyways, so basically put in the prompt, whatever your prompt is going to be, n equals, and so this is going to give us 3 images. So again, if you're just doing testing phase, put this down to 1. No reason to get build 6 cents when you can get build 2 when you're playing around. Again, as you go up, you can do more. Size equals, again, I'm going to put in 1024 by 1024, so this could be 256 by 256, 512 by 512, 1024, just because I think it makes sense. Then we're going to just print out on the screen the full JSON response. We're going to get the JSON response back, and we are going to print out what that whole response looks like, just so I can show you what it looks like. Then we're going to print first or only URL result. And so basically with this, what this is, let's say you only do number equals 1 up here, so you only want the first result. So this will simply print out the URL for the first result only. And then if you want to print out all the URLs, we do a for loop. So for x in response data, that's where all the URLs will be. Print x URL plus stars. And so this will loop through and it will present all the URLs for us. So you will notice here, this is all URLs. Again, in the next lab, I'll show you how to download files. But when you create a file or you create an image using DALL-E, that gets stored up on their servers, up on Microsoft servers as of right now. And they will only exist up there for about an hour. So you'll get the URL, and while you have the URL, you can download the image, do whatever you want with that particular URL. But be careful, do not simply plug that URL into your platform, because after an hour, all the images will disappear. So do be careful about that. So anyways, so now we got that. Now I'm going to hit run. It is now sitting here. It's plugging through. It'll take a second to run. It's actually, I don't know. I think it's actually faster than ChatGPT is generally. So yeah, there we go. See, actually not too bad right there. Let me just do this. Okay, so we go up. So this is the JSON response, right? So we took here, JSON response. So the JSON response is created, so it gives a timestamp for the created. It gives data, then it's 0. So at data, so we come down, scroll down here. So response, data, and then this is the first, this is a list, and we see no commas. So at the 0 index of the list, we have our URLs. So URL number 1, URL number 2, URL number 3. So if all we want is the first and only result, for whatever reason, let's say we're only requesting 1 image, this is how we can get just that first and only URL. Here we have all URLs, so it prints out the first URL, then the second, then the third, all pretty simple. Again, if we go here, I do the control that, and we do open. Let's see what it gives. I honestly have no idea. That's not, I gotta say, they're getting better. They are genuinely getting better with these images. Oh, there's a face. Oh, there's a face that we know and love. It's not as horrible as they used to be, But that still is a pretty crappy face right there. It can't do, I don't know why. Faces and words, DALL-E is just truly horrible at. Then we open up, oops, is that the final image? Yeah, then we open up the final image, and these is what we've got. Oh, yeah, there we go. Look at that face. Oh, look at that face. It's so horrible. So horrible. So anyways, this is, I don't know, a photorealistic image of a kid riding a cat. Which again, it's curious because it's not really photorealistic. Where before, I got some interesting things with pure photorealism. So up here, again, this is a URL. So that URL will exist for an hour. If you want to be able to save the image, you actually have to download it. And that's what we're going to be talking about in the next lab. Okay, so here is some what we call in the tech world some crappy code. What we're going to be doing is we have the same request that we had before. We're actually now going to ask for a cartoon bunny on a whale, because, you know, that's something people want images of. But this time we are actually going to save the images. Now, one of the interesting things when you start talking about saving images is that you actually have to give these images a name. So you have to come up with a name essentially on the fly. So what I'm going to be doing here is I'm going to be using time. So from time, import both time and sleep. And I'm actually going to be using a timestamp as the image name. This may be ugly and horrible, but it does give you something to basically sort off of. So if everything's done by a timestamp, you can sort by the latest, or you know, the image to come up, and it's just one of those things that's relatively simple. So you might not want to use this as a way to save your image files, but again, I've got to show you folks something. It might be ugly, but it actually works like a champ. So here we're going to import OpenAI as we did before. From time, we're going to import the time function and the sleep function. Time is going to be for naming the file. Sleep is actually going to be for sleeping for 1.5 seconds so that we can get a new timestamp. Again, as I said before, it's ugly, but it does work. We're also going to import URL lib.request, and basically with this, we are going to be able to download the images that this particular request creates. We have the API key as we did before, the create image as we did before. This time we're going to do a cartoon bunny on a whale. We are going to ask for 4 of them. Then we're going to come down here, print. So all URLs, so this will simply print out on the command line screen, all URLs for X in response data, name equals time. So this is going to get us our timestamp, but that timestamp is actually going to be a decimal timestamp. That's going to be a float. So then we're going to say name equals, so this is F string, name within int. So basically what this is going to do is it's going to take that decimal and it's simply going to remove the decimal and everything past that decimal point to simply give us an int. An int is a whole number, and then we're going to finish that off with a .png file. So this will only give us .png files. So however you give it the name, you just got to give it a name with a .png at the end. Then what we're going to do is we're going to do URL lib.request URL retrieve. So this is how we can download a file off the internet. XURL. So this is going to be the URL of the image that just got created by this request, and this is going to be what we call this thing when we download it. We're then going to print XURL, so basically what the URL is. We are going to print the name, just so we have that. We're going to print, a little separator thing there, and then we're going to sleep for 1.5 seconds. Again, since we're removing the decimal place, I just want to make sure that we actually get a new solid timestamp so we're not overwriting images. Again, it's ugly, but it works. Now I'm going to run this, right? So I'm going to run this now. It's going to go through and it's going to give us 4 images of a bunny on a whale. At least hopefully. You never know with DALL-E. So all URLs. So there we go. Gives us our first image, gives us our second image, give us our third image, and it should give us our 4th image here in a second. So again, if I do control and I click on one of these, I can do open, and this will show me the image. So again, bunny on a whale. Now what's interesting is I can go over to files, And if we scroll up, we can see that I now have these new images. Again, and this is the naming convention, 169.350, 4682, 4684, 4686, 4689. So those are the images. I can do this. I can do open with other application. I can open with Firefox, and these are the images. So there's a bunny on a whale with like bat wings. I don't really know what that is. There's a bunny on the whale. Wow, I gotta say, I actually have to say, doing this class, they are getting much better. There's a bunny on a whale, and then there's another bunny on a whale with, I guess, a bird. The most important thing here, though, is again, these images are now saved onto this particular computer. So even when that URL disappears in an hour, it doesn't matter, because now I have these images forever and ever. Amen. So now we're going to edit an image. So I have previously created musk.png. So if we come here and we scroll down, and we find out wherever the hell I put musk. There we go. We got musk.png. I can open this with another application. So we're simply going to do this with a web browser. And there we go. So we have musk.png. Now, so this is a PNG with a transparent background. So this is an important thing that I lost a couple of hours trying to figure out with this whole damn edit mess, is basically DALL-E can modify wherever the transparency is. So if you have an image, let's say you have an image of a pool, and you would like to add a pool toy or a kid in the pool or whatever else, you would actually use your image editing software, whatever you use. Again, the same thing, like people don't use Paint Shop anymore. Anyways, whatever Adobe product or GIMP or whatever the hell it is you're using, you would use that. You would actually delete. You would create a transparency wherever you want that image edited, and then you would save that as a .png file. Again, 256 by 256, 512 by 512, or 1024 by 1024. So with this, I took an image of Elon Musk. I basically made the entire background transparent so that it is able to do something with this. Then I can come here, and this is, again, relatively simple right here. Import OpenAI as before, API key as before, create edit. So do make sure you do the create edit. Image equals open, musk.png. So basically you just give it the file location of file name, RB. So this is actually going to read it into bytes instead of the normal read, so this can get sent up and be able to be dealt with. Again, nothing you have to really remember, just use RB. Prompt at a taco stand on the moon, which we've already done. So let's say at a hot dog stand on Mars, because, it's supposed to be going to Mars. Number, again, we can do a multiple of these. I'm not going to waste the pennies at this point. We're just going to do one. You guys get the point on that. Size, and then equals 1024. 1024, whatever, 256, 512, whatever you want to do. 4x in response data, print the URL. So for this particular lab, we are not downloading. That was the previous lab. We're simply going to get that URL so you can see what this does. Then all I have to do is I have to press the run. This is now going to go. It's going to take our little Musk image, and then it's going to put Musk on Mars at a hot dog stand. One of the interesting things that I have found about this, where it errors out in weird ways, if you tell it to put Musk on Mars at a hot dog stand, it will fail out. By using Musk's name, by using somebody's proper name, it will fail out. If you just use the image of the person and say, put this person X, Y, or Z, it will do it. I guess it's probably a weird liability concern. So yeah, you can take any image of a famous person and tell DALL-E to do something with it. Just don't use that person's name. Anyway, so we can hit Control. We open this up, and what do we got? Well, anyways, that's a bit anticlimactic. It's been doing so good on the other stuff. So anyways, we had this image to begin with. I don't know. I don't even know what this is. No idea what this is. What you'll notice here, though, is it is horrible with words. Whenever it tries to spell words, it just does a miserable job at it, and so forth. But yeah, so this is how you're able to edit an image whether it's worthwhile. I don't know. At least it's fun, I guess. Now, for this last lab, what we're going to do is we're going to create a variation, right? So we have an image. We have an image that we've already downloaded. So we have this corgi and we have this cat, and we say we want a variation of this image. Basically do something with this. One of the things that I think is interesting about this particular product from DALL-E, or this particular functionality from DALL-E, is I'm curious what it'll do with copyright. So again, so right now there's a big problem with social media and content creation and all that kind of stuff, where people use other people's content that's copyrighted, and then people go to court and people get sued and it all goes to hell, right? But there's something in copyright law, again, basically fair use, and this is what everybody tries to use, to say that if you modify an image or any number of other things, then basically it becomes fair use. What I think is kind of curious with this whole variation deal is, so you can take somebody's copyrighted image, you can ask for variations, and then just pick the best variation, and that variation is definitely not the original image. So I'll be curious how this works out with content creation going into the future. Again, imagine finding the perfect picture that's copyrighted. You don't want to spend $100 in order to use that picture, so you send it through DALL-E, ask for a variation, and so you get a version of that picture that you can supposedly still use. I don't know. I'm not a lawyer. I'm a geek. Just one of those things to think about. This code is pretty simple, like everything else here. Now, down at the bottom for this particular project, what I wanted to do was actually create an HTML gallery so that it's easier to see the variations, right? Instead of having to click through and see each variation, this way all the variations will actually show up on the page for us. So that's just what I'm doing here. Now, do realize with this, I am simply using the URL. So we're not downloading the images. I'm just simply using the URL to display that on this little web gallery. So if you want to download the image, you still have to do that. Pretty simple, like we had before. Import OpenAI API Key image. So basically here, I'm just going to say what the image is, pets.png. Theoretically, I can put that in my response, but again, using this as a variable value can be useful. So response equals OpenAI.image.createVariation. Image equals open, whatever the image is, RB, again, read as bytes. Number, I'm going to do 5 this time, so we get a decent number of different variations. Size equals 1024 by 1024. Pretty simple. We're going to print out that JSON response as we saw before, just so we know what's going on. File equals open variation.html, W. So this is write, overwrite. So if there already is a file, it will overwrite that file. File.write, img, style, height 250, width 250, border 3 pixels, solid green, and the image for the src, the image. So this is going to show us the original image with a green border around it. Then 4x in response, data, file.write, image style, again, same, 250, 250, border 3 pixel. We're going to make this solid red, so we know what the variation images are. Then we're going to feed the src to be x URL. So again, this is still up on their servers. Then that's going to finish off. Then we're going to print the URL. Then we are going to file close. So now, if I click on the run, it's going to go through and it is going to give us, what did I say, five variations and create a nice little HTML gallery. Okay, there we go. So these are all the images that were created. I won't bother with them. You get the point at this point. We're going to go up here. So I have this sorted by modified. So variation just got created. I double click on variation. And again, so here are our variations. So in the left, in the green, is our theoretically, I hope it's not copyrighted, our theoretical copyrighted work that if we use this, we might get sued. So then we go over and we take a look and see what we're able to use, which might not be anything. Again, this is the interesting with DALL-E. The first time I ran this, again, when we did the demo, I think I got some pretty good images out of that. These are pretty crappy, right? We got, let's see here. Let's do it one by one. So that's the original image. That's the original. That's fine. Look at the face. Look at the face on that cat. That's not going to work. That cat looks so drunk. That's a Hellraiser cat right there. Anyway, maybe not that one. Oh, no, it's still a prairie squirrel cat. The dogs aren't too bad. Dogs, I got to say, aren't too bad. It just didn't like the cats this time. Oh, that poor cat. dog, again, dog looks pretty good. Cat, not so much. And then dog looks pretty good. I don't know what the hell that thing is. I guess that kind of sort of looks like a cat. But anyways, this is the perfect example of why you may want to do numerous images at the exact same time, just because it makes it a hell of a lot easier to get 10 variations. Again, if you do 10 variations, that'll cost you 20 cents every time you hit the run button. And if you're actually doing this in the real world, just paying 20 cents and then picking the best one, might be the best use of your time. I mean, you don't really want to be nickel and diming yourself over pennies. So anyways, those are the examples for how to use DALL-E. Again, I think it's pretty cool stuff, even if the quality of the output isn't the greatest. So there you go. You now know how to use the DALL-E API from OpenAI, right? You just go get the API key. You pay somewhere between like 1.4 to 2 cents for images. Again, 256, 512, or 1024. And then you go and you play with it. The request that you're doing is pretty simple. Again, if you're just asking for an image, you give the query, you ask the number, you say what the resolution is. It will give you back the JSON responses. With the other ones, you actually have to have the original image files. Again, when you have an image file that you either want to edit or get variations of, again, do remember it has to be that stupid ass format, 256, 512, 1024. It does have to be a .png file, but if you do that, everything will go pretty decently. Do remember with the edits of an image, it will only edit within whatever you have made transparent. So if you want a physically larger image on your image, if you want a physically larger edit on your image, you'll actually have to cut a bigger spot. Again, one of those things to be thinking about when you play with this particular system. But again, I think this is kind of cool for things like party tricks. Imagine if you used OpenCV. So OpenCV is a computer vision framework that allows you to do things like detect faces relatively easily. So imagine if you were doing like an entertainment company, like a party type company. Imagine if you created a piece of software, use OpenCV, so people would stand in front of it. It would basically find where the faces are. It would then delete everything other than the face, and then it would put those people at a taco stand on Mars. Or, something that DALL-E thinks is a taco stand on Mars, right? That might actually be an interesting thing, like a kind of product that you would use in some kind of party situation, that type of deal. But again, that's where this is interesting, where as an API, you can start tying this into a larger system. It's like, okay, so somebody stands in front of a photo booth, then you have a Python script that runs OpenCV. OpenCV detects the image. OpenCV grabs the face out of the image. It deletes the rest of the background. You then pass that image now to DALL-E to insert a background of some sort. And then you pop it out. Maybe, again, you use Twilio to send them an SMS message with their picture. Right? And that's where service-oriented architecture comes in. OpenCV does a computer vision, DALL-E does the image editing, Twilio then sends the finished product to the user, and of course, you collected their telephone number when they did that. Because if we're not slightly evil when we create our products, we're just not doing it right. But anyways, right, that's the kind of thing to think about with this. Again, DALL-E, I do have to say the original images, when we were just asking for images, those actually came out much better than I was expecting. But as you can see, the edits and the variations are still pretty wonky. I think one of the most important things with this is, again, think about it as a component within a platform that you're building. Like, this may not be what you need now, but if you're building a platform, this can be the placeholder. Possibly, OpenAI will make this better over the next 6 months, and so you just leave it there. Or, again, Midjourney comes out with an API, or whatever, one of these other providers comes out with an API. And again, literally, as I literally showed you, it's like 5 lines of code. You just swap out 5 lines of code and go from there, right? And that's a kind of cool thing with service-oriented architecture. And that's why I think it's fun to play with this right now, even if, I would not put this into a production environment. Other than that, I don't know, don't really think there's any warnings. There's no warning, Will Robinson on here. Should work with whatever system that you have. Again, we're using VS Code in order to do this. And so yeah, plug in your credit card number and away. You should be able to have some fun with this. As always, I enjoyed teaching this particular class and I look forward to seeing you at the next one.